Hi students, now I am giving some questions of 3D, 3-dimension geometry. There are 3 axes on 3-dimension, x-axis, y-axis and z-axis. Then these 3 axes are perpendicular to each other. First question, direction cosines are cos alpha, cos beta, cos gamma. Direction angles alpha, beta, gamma. Direction ratios DRs denoted by A, B, C. DCs are denoted direction cosines. DCs are denoted by L, M, N. Therefore, L equal to cos alpha, M equal to cos beta, N equal to cos gamma. L equal to plus or minus A by root of A square plus B square plus C square, and M equal to plus or minus B by root of A square plus B square plus C square, and N equal to A by root of A square plus B square plus, we can add this plus or minus, but according to the quadrant or octant it will be changed. So always we are taking, in the most cases we take positive values, only positive values. So plus or minus A by root of A square plus B square plus C square. Then there is relation between Lm and L square plus M square plus N square equal to 1. Therefore, one result can be written, that is cos square alpha plus cos square beta plus cos square gamma is also equal to 1. Then we want to study the equation of lines here. In that, first one is equation of a line passing through one point and parallel to a given vector. There are two forms, vector equation and Cartesian equation. So question is like this: the equation of a line passing through one point P x1 y1 z1 and parallel to a vector vector B. There are two forms, vector equation and Cartesian equation. Vector equation is denoted by VEQ. Vector equation is vector r equal to vector a plus lambda vector b. Vector equation is vector r plus vector r equal to vector a plus lambda into vector b. And Cartesian equation is can be denoted by CEQ. Here x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, where x1 y1 is the given point. Vector a is position vector of PV, position vector of given point. P x1 y1 z1, and vector b is parallel vector. A, B, C are DRs of parallel vector. This is first case, this is second case. And the next one is equation of a line passing through 2 points. Line passing through two points P x1 y1 z1 and Q x2 y2 z2. Position vector of P is vector A, and the position vector of Q is vector B. First one, vector equation is vector R equal to a vector A plus lambda into vector B minus vector A. And 2, Cartesian equation. Cartesian equation is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Next one is, next heading, angle between two lines. Angle between two lines. There are two cases, vector form and Cartesian form. If we are writing vector forms, then we get vector equations. And when we want to find out the value in Cartesian form, we need Cartesian equations. So we know that vector equations and the Cartesian equations of two lines, vector form is form cos theta equal to vector b1 dot vector b2 divided by mod vector b1 mod vector b2. Cartesian form is cos theta equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Where vector forms are vector r equal to a plus lambda b1, a1 plus lambda b1, and vector r equal to vector a2 plus lambda b2. From that we get b1 and b2. In Cartesian form, x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. And second line, x minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. From those we get a1, b1, c1, a2, b2, c2. Then condition 4, perpendicularity of two lines. If two lines are perpendicular, the equations are given in vector form. Two lines are perpendicular, then vector form. Vector b1 dot vector b2 equal to 0. And a Cartesian form, a1 a2 plus b1 b2 plus c1 c2 equal to 0. Then condition 4, two lines to be parallel. Two lines to be parallel. Vector form. Vector b1 cross vector b2 equal to 0. Or another condition is also for this, or vector b1 equal to, that is condition of parallelism, vector b1 equal to lambda into vector b2, where lambda is any constant. Any constant. In Cartesian form, a1 by a2 equal to b1 by b2 equal to c1 by c2, where a1, b1, c1 are direction ratios of first line. a1, b1, c1 are drs of first line, and a2, b2, c2 are direction ratios of second line. These are the formula which we want to study. Here we want to study only lines, equation of lines and angle between them. Then condition for parallelism and condition for perpendicularity. And then we want to write point on point. X-axis is x 0 0. point on y-axis is 0, y, 0. Point on z-axis 0, 0, z. Point on xy plane. Point on xy plane is x, y, 0. And point on yz plane. Here x, no x, so 0, y, z. And a point on xz plane is x, 0, z. And origin. Origin 0, 0, 0. Distance between two skew lines. Vector form. Given lines are, first we want to write the given lines. Vector R equal to V1 and vector R equal to vector A1 plus lambda B1, vector A2 plus lambda vector B2. In skew lines, this B1 and B2 are different. We can write this lambda as mu, not they are also different. So it becomes mu. It becomes mu. Okay. Then vector form D equal to mod vector B1 cross vector B2 dot vector A2 minus vector A1 divided by the total mod of divided by mod B1 cross mod B2. Then next one is Cartesian form. Given lines x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1, and x minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. Then Cartesian form is D equal to determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 divided by root of a1 b2 minus a2 b1 whole square plus b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square. Then distance between two parallel lines. Given equations, vector r equal to vector a1 plus lambda vector b, and vector r equal to vector a2 plus lambda vector b. Here please listen, in parallel lines the b part will be same. In skew lines, again here we want to take this as mu, not lambda, mu. Vector a2 plus mu vector b. So this b part, vector b part are same. So here d equal to mod vector b cross vector a2 minus vector a1 by mod vector b. Mod vector b. Then this is the result. Then when vector form is given, we want to change it into Cartesian form is given. Then we want to change it into vector form. Then we want to find this. So d is equal to mod vector b cross vector a2 minus vector a1 divided by mod vector b.